Hi everyone, what's up? Welcome back to my tutorial channel. It's Daniela Chuan here, and today we are going to continue to work on some more IFM practice problems that collect us from the exam. This section is 4-1, the core level. Alright, so first problem. The return of an investment R has the following probability mass function. The probability that R is equal to little r is equal to 0.05 when R is negative 8%. It is 0.2 if R is negative 4%. It is 0.3 if R is 1%. It is 0.3 if R is 5%. And 0.15 if R is 10%. Determine the value at risk at alpha is equal to 5%. So, remember that the value at risk is the value of R that separate the lowest alpha percent to the 1 minus alpha upper. So here, let's look at the possible values. Here we have only 5 possible values. Negative 8%, negative 4%, 1%, 5%, and 10%. These are 5 possible values of R. So we need to find a value of R that is separate the lowest 5%. So if we look at R is equal to negative 8%, the probability that the random variable R is less than or equal to little r is exactly 0.05, which is 5%. See that? Similarly, if we choose R is equal to negative 4%, then the cumulative probability function, or the probability that R less than or equal to negative 4% is 0.2 plus 0.05, which is 0.25, is more than 5%. So simply we should pick R is equal to negative 8%. See that? Solution. There are 5 possible values of R's. Negative 8%, negative 4%, 1%, 5%, and 10% in ascending order. See that? Now notice that probability that R is less than or equal to negative 8% is probability R is equal to negative 8%. Because we have only 5 values of R, and negative 8% is the only value that fall into the negative infinity to negative 8% range. So that's why this probability is exactly the mass function probability, and it is 0.05%. And it is 0.05 or 5%. So basically, probability that R is less than or equal to negative 8% is 5%, which means the value at risk at 5% is negative 8%. So the answer is negative 8%. Alright, problem 2. The distribution of the project return is unknown, but the following sample inverseness has been obtained. We got a sample with 10 individuals. Determine the sample estimation. In order to determine the sample estimation, we need to first determine the sample mean. The sample mean is calculated by adding all the numbers together and divided by the sample size. So we got 3.1, and from here we calculate the sample variance. Sx squared is equal to 1 over 9. Here the sample size 10. For the sample variance we have to use n minus 1 at the denominator. And for each of these numbers we subtract 3.1 from each of these numbers, take the square, and then add all the square together. So the sample variance is 12.54. And from here, we take the square root to determine the sample estimation, which is 3.5%. Problem 3. The distribution of the project return is unknown, but the following sample inverseness has been obtained. We got a sample of 10 different numbers. Estimate the value at risk at alpha is equal to 15% using the order data value x alpha n plus 1, and then use the linear interpolation if necessary. Alright, so again, the value of risk alpha is equal to 15% should be the value of the project return that separate the lowest 15% from the highest 85% from the data set. So this is a problem that we work with order data sets. So before we do any calculation, we have to arrange the data set in ascending order. So first arrange the data set in ascending order. We got -3, -2, -1, 3, 3, 5, 6, 6, 6, 7. There are 10 numbers total in total. Alright, now we need to find the value of risk at alpha is equal to 15%. So we have to find the order of this value of risk by following the formula alpha times n plus 1, where n is the sample size, which is 10. So we got alpha times n plus 1 is 0.15 times 10 plus 1, and it is 1.65. So 1.65 is the order of the value at risk in this data set. And we see that 1.65 is between 1 and 2. So the value at risk should be between the first and the second number. Here the first number is -3 and the second number is -2. So the value at risk should be somewhere between -3 and -2. For some simple calculation, some people to take the average. But for the precision, we need to find exact value, so we are going to apply the linear interpolation. So let's say this. Look at the diagram. Here I have a diagram. First I sketch up the x-axis, and since the order of the value at risk is 1.65, so I'm going to just consider the segment between 1 and 2, because 1.65 is between them. So on this diagram, you see that the upper numbers, the upper marks, represent the orders of the data set, the orders of the numbers, and the bottom marks represent the value of the numbers in the data set, corresponding to its order. So we see that 1.65 is between 1 and 2, between the first and the second number. The first number here on the data set is -3. You see it? This is the first number on the data set in ascending order. And the second number is -2. So I mark -1 under 1 and -2 under 2 because -1 is the first number and -2 is the second number on the data set. And let's say x is the number whose order is 1.65. So now we are going to use interpolation. I call D is the length of the segment between 1 and 1.65, and L is the length of the segment between 1 and 2. So if we consider the ratio D over L, we got D over L is 1.65 subtract 1 over 2 subtract 1, and it is also x minus -3 over -2 subtract -3. And from here we just have to solve for x, and we got 0.65 is equal to x plus 3, which means x is -2.35 in percentage. Here all of these numbers are in percentage. That's why I keep percentage here for the units of measurement. Problem 4. The return of a project R follows a uniform distribution with the following probability density function. FRR is equal to 1 over 0.15 for R is between -0.05 and 0.1. determine the standard deviation of R. In order to find the standard deviation of R, we have to apply the formula variance of R is equal to ER squared minus ER whole square, and standard deviation of R is just the square root of the variance. And this is a continuous probability density function, so we are going to use integration to evaluate ER and ER squared. ER here is integral from negative 0.05 to 0.1 of R times FR dr. So it should be R over 0.15 in the integration, and we got 0.025. This is a very basic integration. ER square is integral from negative 0.05 to 0.1 of R squared FR dr, and it should be 0.0025, and we got the variance. And then take the square root to find the standard deviation. Problem 5. The distribution of a project's return is unknown, but the following sample in percentage has been obtained. Estimate the value of risk at alpha is equal to 15% using the n order statistics, or xn using the order data value xn is equal to x of 1 plus alpha times n minus 1. Use linear interpolation if necessary. Alright, so this problem is similar to one of the problem that we just worked in a couple of minutes ago. Now, first we have to arrange the data set, right? And we have 10 numbers totally. Now we need to determine the order of the value at risk at alpha is equal to 15%. We got 1 plus alpha times n minus 1, which is 1 plus 0.15 times 9, and we got 2.35. The value at risk at alpha is equal to 15% should be somewhere between the second and the third values. And now we look at the diagram. On this diagram, I marked the orders of the data on the top numbers, and the bottom numbers are the value of the data set. So the ratio between between D and L, D over L should be equal to 2.35 subtract 2 over 3 subtract 2 using the upper scale, and it is also equal to x minus negative 2 over negative 1 minus negative 2 using the lower scale. And from here we solve for x. We got what, negative 1.65 in percent. Alright, so that's it for today. Thanks so much for watching. If you like this video, please like, share, and subscribe. See you on the next video. Bye bye.